Good Good afternoon, and thanks for joining us today. We're very excited about this program and the opportunity to introduce you to Eclipse Automation. My name is Jason Boscher, and I'm the president of our Southwest division located in Mesa. Joining me today is Todd Best, our engineering manager, as well as Adam Radley, our shop supervisor. Here's how we plan to break down our presentation for you this afternoon. We'll be explaining a little bit about who we are as a company. We'll touch on what industrial automation is and what it means. And then we'll take a look at our approach to building equipment and what role each of our departments play in creating the best solution for our customers. And then we'd love to answer any questions that you may have. So a little bit about who we are as a company. At Eclipse Automation, we design and build and install automated equipment used for manufacturing in a wide range of industries. Our focus is to build equipment that is specific to our customers' products or processes that can't be achieved by using standardized equipment. The word Eclipse means to become greater in amounts and levels than something else. And the way we interpret that meaning is written into our vision statement, which is to live up to our name by inspiring and creating outcomes that change the world. This means that our focus is to make our customers better at what they do so that they can be better at improving the lives of the consumer. We do this by using the know-how that we've learned to really care and understand what our customers need, and then create solutions that are right for them. Each project requires something unique in order to be successful, and understanding what that is and then doing it, that is what we get excited for, and that's what we do. Although we design and build equipment, we really are a know-how company. And to build know-how, we believe that we need to continue to learn from what we do every day in order to provide solutions that are best for our customers. It's improving on our skills and increasing our knowledge and learning from the challenges of one application or industry and applying it to other projects or customers across different industries. It's that thirst to learn new technologies and processes that motivate us and drive us to passion for our work. And we look at developing know-how like the belt system in karate. Where each belt level or color builds on a story of new light growing into a tree that is full of color and enlightening those around them. So we work on building the know-how of our employees from what they learn from you into people that are experts in their professions who can empower the next generation. And that's why we're really excited to be doing this presentation for you today, because you're the ones developing the white belts, the birth of a new light, depicting a person who starts to learn about their profession, keeping in mind the different challenges that they're going to face. Eclipse Automation was founded in 2001 and has grown rapidly to over 800 employees worldwide across 16 sites. What you see here is a picture of our facility in Mesa, which has over 26,000 square feet of manufacturing space, and where we employ all the disciplines needed to design and build our equipment. Our footprint is global, and you see that by the dots here on the map, in order to provide more localized support for our customers, but it also provides exciting opportunities for our employees to travel and work at locations all over the world. We take pride in providing automated solutions for many different industries, including life sciences, transportation, energy, consumer goods, electronics, and industrial products. We're able to apply different technologies and processes from one industry to another, and it allows us to think outside the box when we approach our new project. It also allows us to move with the ups and downs of each industry. And as you can imagine, this was a big factor for us this year, as industries came to an almost standstill overnight, and where other industries suddenly couldn't keep up with the demand. So we thought we'd take a step back and talk a little bit about what industrial automation is. Industrial automation is the use of control systems, such as computers, robots, or other mechanisms, as well as information technologies for handling different processes and machineries in order to accomplish an outcome that's not easily achieved by a human. This includes increasing productivity and reducing costs, improving quality of the product and the consistency in which it's made, as well as reducing scrap. It's increasing the flexibility in ways products can be made, or providing the ability to change how products are made quickly. And it's improving the safety of the people building the products. This usually means improving ergonomics and reducing injuries caused by repetitive tasks. So we found a good video that explains what automation is in a bit more detail that we'd like to show you.
Industrial automation is a set of technologies that uses control systems and devices, such as computer software and robotics, to enable automatic operation of industrial processes and machinery without the need for human operators. Industries implement automation to increase productivity, eliminate the possibility of human error, reduce costs, save time, and achieve higher performances. A wide range of tools are required for industrial automation. They include various control systems that incorporate different devices and systems impacting aspects of the manufacturing process. These automation devices include PLCs, HMIs, SCADA, robotics, and more. A programmable logic controller, or PLC, is a rugged industrial computer designed for the control of manufacturing processes. PLCs can work as standalone units that can continuously monitor and automate a process or specific machine function. PLCs can be networked. Such a network can control an entire production line. PLCs are used in industrial automation to increase reliability, system stability, and performance, minimizing the need for human operators and the chances of human error. An HMI is a software application that enables interaction and communication between a human operator and the machine or production system. It translates complex data into accessible information, enabling better control of the production process and its various applications. SCADA systems control and monitor industrial processes. The system acquires and processes real-time data through direct interaction with the devices, such as sensors and PLCs, and records events into a log file. SCADA is important for data analysis and enables effective decision-making for optimization in industrial processes. Robots can efficiently perform tasks in complicated or dangerous situations, improve production flow and quality, and increase safety for employees. Automation of factories, manufacturing, and processing plants can improve production rates. It helps improve mass production by drastically reducing assembly time per product and improving the quality of production. Therefore, you will typically see a good return on investment in terms of the resulting output.
So we wanted to share in more detail our approach to building equipment and what roles are required to achieve this from an engineering and build point of view. So we figured what better way to describe all the disciplines involved in creating a piece of automated equipment than to take a project that we've done recently and walk through the process of designing, building, programming that piece of equipment. So our customer approached us with a problem. It was how to take a medical centrifuge tube and place information labels on them consistently at a rate of 100 parts per minute. The labels needed to be accurately placed around the tube, and they needed to be placed correctly each time. It was very important that every tube was inspected to ensure that the labels were present and placed correctly. So here's just a quick video that we took to show this piece of equipment to you.
Here's a quick overview of the machine. What I'll do for those of you who don't know, Mike Barzano is one of our lead tool makers and one in charge of this machine. I'd asked them to just do a quick overview of what's going on with this system. And it does these little tubes and puts a label around it here. And this is the bowl where it all starts. And then this is probably the biggest bowl I've ever worked on. And as it comes down out of there, it comes down into this inline. It's on almost a 45-degree angle. And this thing does pretty good. And then it brings it down into the star wheel, which Eclipse designed. And then coming out the front, we have a sensor there at the front of the star wheel, which does the timing for us as we bring off a part every 2 rollers. And then it comes down and it eats our needle labeler, which works very good, and puts a label on the bottom at the specified specs that our customer requested at. And then it comes down to number 9 here, where this is a roller and it rolls the tube and makes the label concentric all the way around the tube. And then right after 13, you see a camera there. That's our inspection station. And then the 3D printed chutes there. The first one is the reject. The second one is our first offload bin. And the third one is our second offload bin. And those take 480 parts each.
And then how fast is this thing supposed to run?
It runs 100 parts a minute, and we do 107 parts a minute.
And then we just did an FAT run, and we were between 99.98 and 100% OEE.
Yep.
So it runs really well. So let's fire this thing up, and you guys can see a quick video of it operating.
So our focus today will be on engineering and build processes, but there are many other areas that have a significant impact on successfully completing projects that we do. We have applications engineers, which concept and price the equipment. So many of those people have been in the industry for many years and are able to apply their experience to understanding the efforts required to execute the project. We have supply chain professionals who support procuring all the parts that we need on time and at prices that allow us to be cost competitive. And project managers work tirelessly to keep projects moving forward on schedule, within budget, and to the scope of work that the project was sold to. So I'm going to hand this over to Todd Best, our engineering manager, who will outline the processes during the engineering phases.
Good afternoon, everyone. As Jason mentioned, my name is Todd Best, and I am the engineering manager at Eclipse Automation Southwest in Mesa. So our engineering team at Eclipse is tasked with taking the concept or approach that's been sold to the customer and turning that into a producible design that meets the functional requirements of the application. So to borrow a term from Disney, we're the Imagineers, so to speak. But instead of creating an entertainment product, we develop the equipment and the processes required to produce a sellable product for our customers. And that may not sound as exciting as a ride attraction, but it is very rewarding and satisfying work. We get to utilize cutting edge technologies and apply proven methodologies to solve the most challenging applications. And as an integrator, Eclipse works in many different types of industries and applications. So every project is very different. The scope, scale, and challenges in each project can vary to a significant degree. So it never gets old, repetitive, or boring. So how do we develop these creative solutions? Well, we employ a multitude of engineering resources to develop the projects. This includes mechanical engineers, electrical engineers, software developers, or programmers, as they're commonly referred to, and robotics engineers. And approximately 1/3 of the resources within the Eclipse organization are of engineering disciplines of these types. I'll talk about each of these roles in more detail as we move forward, but on a high level, the engineering team assigned to a project must be able to interpret what's been sold to the customer, determine the best solution to, excuse me, to create the deliverable, be cognizant of the cost and the schedule of what we sold to the customer and when, communicate issues, risk, and concerns internally and with our customers. And of course, they've got to provide the engineering and programming development efforts to make the system operate as intended. And we always support our projects once they've been delivered to the customer. So many times the engineering team is involved in installation and ongoing support for the life of that project or application. So the design process starts with mechanical engineers. The mechanical engineers lay out the system based on the idea or the concept sold. They perform many of the critical and analytical calculations required to specify and select all of the mechanical hardware. They design the tooling and the components required for the design, create the manufacturing drawings, and coordinate efforts between the mechanical and electrical team to ensure the design criteria is understood by all. Mechanical engineers must be familiar with engineering calculations, such as load and stress analysis, kinematics, pneumatics, power systems. They must understand what manufacturing processes are required to make a part and what are the appropriate materials those parts are to be made from. And nowadays, everything is designed in 3D CAD, so we use 3D CAD software to create and visualize the design as they develop it. This allows all the team members and even our customers to understand more clearly how the final product will look on the floor. The brief video you just saw is the CAD design of the tube labeling system that you just saw a video for a few slides back, for example. And lastly, mechanical engineers must organize and maintain a large database of drawings in our product management system, or our PDM system as we refer to it. We also use electrical engineers in the design process, and electrical engineers design and specify the electrical devices and hardware required to run an automation cell. They start by evaluating the project scope, specifying the main controls architecture for the system, reviewing the safety aspects and all of the requirements for the project. And then they fully design the wiring schematics for the system, which includes every component in the electrical enclosure and basically every device on the project or the machine that has a wire attached to it. To do this, they must understand all major industry codes for electrical and safety, as well as the customer requirements and the utility requirements that are available in the customer's facility. So as part of the electrical design, they also design the physical layout of the electrical components in the enclosures. Every detail of this design must be captured all the way down to wire color and size. So it's a very detailed process that electrical engineers go through. Electrical engineers also support the project during the build phase to ensure the system functions as intended and operates within the project requirements. Software developers, or the programmers, create the software and the operational control system, integrate and debug the process, and rigorously test the result to ensure the machine functions as it's supposed to. These days, software development is the true heart of automation systems today. With the rapid rate of technology advances, software can make a proven mechanical design faster, more efficient, or less costly to develop or upgrade over time. They begin by analyzing the process. What is the machine supposed to do? How much time does it take to perform each operation or process, and what steps are required to complete it? They then write the software code to perform these logical functions and make the machine functional as intended and operate safely for their users. Code is written in special machine language on programmable controllers or PCs typically. The code is defined in a logical manner based on devices in the system and the sequences they need to execute. A software developer must look at multiple inputs and outputs on the system and determine how to manage those. For example, there may be devices that are providing feedback, such as a sensor, and that the feedback from that sensor may trigger what happens or is actuated next in the process. And safety is a very important aspect of any automation process. So programmers must also set up and program all of the safety requirements of the system so an operator can work around the equipment without risk of injury or prevent the machine from damaging itself. These software developers also are tasked with creating the visual interface that the operator utilizes to operate the machine. We typically call it an HMI, or human machine interface. It's a graphical interface with touchscreen buttons to allow them to adjust parameter settings, display data, troubleshoot the machine, clear faults, and operate the machine in a manual or offline mode as well. And when they're creating these screens, and you see an example of it on your screen right now, they must think in terms of what the user needs to see and access in normal daily operational modes and provide an intuitive functionality to it. Once the system is powered on and developed, or powered on the floor, I'm sorry, the software developers install and configure the programming on the machine, test all the devices and the operational modes, safety aspects, and so on. And then they refine the performance or debug it to meet the project requirement. The software developers generally will go on the customer site to support ramp up at install and ready it for production startup. Many of our projects have robots on them or motion systems. So we also have robotics engineers that are tasked with specifying and designing how a robot or motion system interacts in an automation process. They start by specifying the robot based on what it has to move around, the mass of the object, and how it has to be manipulated in the process, and where, how fast, and how precisely it has to be positioned. The robotics engineers utilize software tools to help analyze the robot selection, create the program, and simulate the robot movements in the design phase of the project. The video on the left side of this slide shows the simulation Eclipse developed for an automotive robot application early on in the project. And then the video on the right side is the same process once the machine was running on our floor, for example. And then once the system is built and powered on, the robotic engineers install and configures the robot programming, test all of the steps, fine-tunes the positions, and moves and optimizes the overall performance of the robot to meet the application requirements. So that's a kind of a very high-level summary of some of the key engineering disciplines that we utilize in an application project. So all of these engineering disciplines obviously require a certain level of technical competency and education. Many of the roles I presented require at least a 2-year degree to provide that resource with the foundation to start their career. And with the ever-advancing state of technology that we have these days, engineers also need to have the mindset to be proactively to continuously improve their skills and expertise. So companies like Eclipse actively encourage their employees to advance their skill set and knowledge by providing educational reimbursement and on-the-job training opportunities throughout their careers. When we get to this point where a project moves from kind of a virtual world to a physical world on our floor, it's very exciting to see when that program is installed and robots and other devices start moving. And you get to see the results of weeks or months of effort to get to that point. But to see the results of those efforts, the automation system must be manufactured, assembled, wired, and powered, and those efforts fall to our shop team. To speak more on that, I'll hand off to Adam Bradley to discuss the build process.
Hello, everybody. As Todd said, I am Adam Bradley, the shop supervisor for Eclipse Automation Southwest and Mesa. In the shop here at Eclipse Automation, we take the designs and plans that have been created by our engineering teams and turn them into reality. So basically, we take all the wonderful electronic drawings and designs and schematics that Todd's team create, and we make something real out of it. Nothing is more satisfying than working together to take concepts or ideas from paper or electronic space to physical working equipment. In the shop, there are many specialized roles that our team members perform to make this a reality. Let's take a deeper look at these skilled trades. So the first one I'm going to talk about is the fabricator welder. A fabricator welder will use design drawings developed by our engineering team to create frames, brackets, large welded assemblies, and precise specifications. The fabricator welder will use tools like saws and grinders and gas arc cutters to produce the pieces that will be constructed together or welded together to make full assemblies for our projects. The next role I want to tell you about is a machinist. Here at Eclipse, we employ many machinists, and the machinists create very precise machine parts for our automation equipment designs. The machinists often create parts with features that are held to very, very tight tolerances. Each part will be created to exact specifications that are defined by our mechanical engineering team. The machinist will use a multitude of machines to create these parts, including, but not limited to, manual mills and lathes, computer numerical controlled milling and turning centers, or CNC machines, precision surface grinders, wire electrical discharge machining, or wire EDM machines, as well as 3D printed technologies as well. That's an up-and-coming thing these days, and we employ it here at Eclipse Automation. The shipper and receiver is also an important role in our shop. Generally, you would think about somebody that's doing shipping and receiving as maybe a low-level role, but that's not really the case here, because there's a lot on the plate for that person here. The role of shipper and receiver is responsible for receiving in and verifying purchased parts, materials, devices, and anything else that's used to create our automation devices. The shipper and receiver will inventory all received in goods and distribute them to the various areas of the shop where projects are being built. The shipper and receiver will also manage machine parts that are sent out for outside processes, such as anodized coatings and zinc coatings and other paints and processes. Lastly, the shipper receiver also helps manage, package, ship, and organize all of our outgoing shipments and finished product as it leaves the building. Once all of the purchased items, machine parts, and fabricated assemblies are complete, the machine tool builder integrators, or we call them MTBIs here, will begin their task. And they're really doing the meat and potatoes of the work here. They're going to put everything together. They're going to build the Lego project. The MTBI will gather and organize all the physical components of the project. They will plan the build, and starting at the smallest levels of assemblies, the MTBIs will assemble all the parts of the design. Once this is complete, the MTBI will install and integrate all of the pneumatic systems, electronic sensors, and any other specialized equipment that's required. Once all of the electrical items have been wired and powered on, the MTBIs will test the functionality of each system and piece of equipment and fine-tune it to perfection. After the equipment has been completed, tested, and approved by their customer, the MTBI will deconstruct the equipment, prepare it to be shipped to the customer site, where once it is shipped and arrives at the customer site, those same builders will be on the floor and they'll reconstruct the piece of automation equipment. And it once again gets tested and tuned again if needed. And then it gets approved by the customer once again. An electrician here at Eclipse is responsible for building the electrical panels that house all the electrical control systems for our automation solution. Once these panels are built to design specifications of the electrical engineering team, the electrician will connect the panel to all the electrical systems that are in the equipment. After all systems have been connected and checked for safety, the electrician will power the equipment up and begin to test and tune the electrical systems. Once the equipment has been tested and approved by our customer, the electrician will assist the MTBIs in dismantling the equipment and travel to the customer site and help reassemble it and test it once again. The knowledge and skill that each of our team members bring to the table is what makes Eclipse a leader in the field of automation solutions. All of our build team members have trade skills that can be applied in many other areas of manufacturing, not just automation. Eclipse Automation has an apprenticeship program for each of our skilled trades, and each year we help young people start their career in manufacturing. The Arizona Department of Education offers an automation and robotics program. I think it's geared towards high schoolers. This program is a great opportunity for students to get their hands on equipment and automation robots. You can find out more about this program by visiting the Arizona Department of Education's website. That's our presentation for the evening. I'd like to thank you all for listening and watching our videos and hearing about all the wonderful things that we do here at Eclipse Automation. And I'd like to open the floor to any questions that you may have.
Hi, I do have a question. So your shop team, what kind of degrees are you looking for your employees in the shop team?
Well, somebody on the shop could actually start as an apprentice without any type of degree whatsoever. But typically, there are local trade programs at the community college level that you can go through to get a jump start on your education needed for a skilled trade job. But you can also be in the apprenticeship program while you're doing that, and we would help.
Are there any programs within JTED, if you're familiar with JTED, that you would recommend for any of your positions?
I am not familiar with JTED. Jason, are you?
Not either, no. We can get some more information. We can put our contact information in the chat here, and then you can send us a message, and we can definitely look into that in more detail.
Okay, thank you.
Debbie, I do know that this is Aaron with Center for the Future of Arizona. Sorry, Jen.
Yes.
Depending on the area that you're in, and I apologize, I don't remember where you're at.
Tucson.
But, okay, great. Look at the Pima County JTED has a manufacturing program.
Yeah.
A couple of the high schools do as well. West-MEC out in West Valley of Phoenix does. EVIT in the East Valley, EVIT CTED does as well. So I encourage you to take a look at the CTEDs. And then, as Adam was saying, the community colleges, most of the community colleges in your area have some sort of automated industrial technologies program is the program that they really look at.
Pima does. Yeah, Pima College.
Exactly.
Yeah, they do have a good program.
So, yeah, great question.
Yeah.
Do you guys see a lot of people who start off as an apprentice stay for a long time? What's the average, 3 or 5 years? And how's the turnover rate in the industry?
Turnover rate at Eclipse has been very good. I think all our apprentices have stayed on or have stayed on so far. Our turnover rate's fairly low. Adam, you've been with a number of other companies. I don't know what your thoughts are on the turnover rate in general.
Yeah, I've also seen a very low turnover rate. Typically, students that put forth the effort to go through an apprenticeship program, they succeed. And I've seen many times people go through an apprenticeship program and work their way up into higher positions out of the shop even. I've seen several CNC machinists go from floor machinists through an apprenticeship program straight up into programming positions and lower level engineering positions.
I think one of the things that helps with retention in our industry is just the variety of projects and applications we work on. Just to kind of speak about, whether they're in the shop or in engineering, you don't sit there and you don't do the same thing every day. You're not making 500 of the same parts every day kind of thing. It's very different from one day to the next. And I think people who like that variety and that challenge tend to stay, in companies that provide those kinds of opportunities.
I think one thing that our company, I think one thing that our company offers as well is when you're out on the shop and you're working on one of our projects, you get the opportunity to be involved in more functionality than just your role. So say you're a machinist on a project, you may get pulled into meetings and get to give your input on the engineering portion of that project, or you may have an idea to help the automated solution work a different way, and that end up getting implemented. So I think that it offers our employees a chance to see the other parts of the industry that they could possibly move into if maybe they decide that the role that they're in right now is not where they want to be.
And just to add to what Adam was saying, we do turnkey solutions here. So we design it and build it and make it run. So somebody who's made a part on a milling machine can actually see how that part is used in an application. It's not like they're making a part that they ship off and they don't know what it does in the real world. I mean, I think that also helps keep people engaged and want to grow within this type of industry as well.
My other question was, do you have a sales team, or do you pretty much rely on the companies knowing who you are and just seeking you out? And if you do have a sales team, what type of qualifications?
We do have sales team. So we do have, it's kind of split into two aspects of it in terms of sales and business development. So there are people that are going out and interacting with the customers and drumming up leads, and then they're bringing those leads back to an applications engineering team, which are working on developing the concepts and pricing it all out and writing the quotes that we send to our customers. So in general, most of those people that are on our sales team, I would say most of them have an engineering background, but that's not always the case. Some of them also have like a business administration or a marketing background as well. If they've got more of a technical aptitude, they are able to pick it up, and the sales team don't necessarily have to be experts at the technology solution, right? They can lean heavily on the applications engineer to talk more about the technical details of the concept and the price. They need to be involved in building that relationship with the customer and finding new leads. So it doesn't have to be an engineering background for that role. It could be more on the business administration or marketing.
Thank you.
Any other questions?
There was one in the chat.
Yeah.
This all seems very complex. Right now in my class, we're going over the importance of communication. Do you ever find when developing a software for a company, there's a translation issue? And then to you, the vocabulary is in your everyday conversations, but do you ever run into companies not being able to translate instructions? So say, and Todd, you can probably jump on this a little bit. There's definitely two streams of communication and how it applies to software. So one of it is just normal verbal and written communication to be able to interact with other team members and to customers, and that's very important. And then the other aspect is learning a completely different language, which is the language that's used to actually design or program the equipment. And that language, although understanding the specific language that the operators are going to be using is very important. It has a different role as well. So yes, communication is important. It's important to work within your team, and it's also important to be able to, especially the user interfaces that are on the equipment, to be able to portray the right information to the operators that are using it. So that could be just as easily translated from someone whose English is a second language to English, but vice versa as well, right? Someone who understands English very well, but we're installing a piece of equipment in another country that doesn't speak English. We need to translate it the other way, and we need to be able to translate it in a way that the people who are operating the equipment will know how to use it. So especially for people that are English as a second language, is still very important to us because we have equipment that's going to other countries. Spanish being a particular one of interest to us because we do send a lot of equipment down to Mexico. Being able to speak the language, especially from a technical point of view, is very advantageous. So those people that are learning English and learning English as a second language, we need those people too, just because they bring a lot of benefits that someone who has grown up understanding English can't be able to communicate that well to our customers in another country.
That's a good question.
Yeah, just to add to that, I would say in general, that's communication is just as important as the technical competency that engineering team members need to have. As Jason mentioned, they speak one language which is very technical and complex, but they're also dealing with people that may not have that technical level of understanding, and so they have to communicate their progress and issues and questions in more of layman's terms, so to speak. We have a number of measures that we employ to try to make sure our customers understand what we're developing, because if we just show them a bunch of lines of code, unless they've got that expertise, they're really not going to understand what they're looking at. If I could show my screen for a brief moment, one of the tools that we use to provide a level of understanding for our customers is, here's an example of what we call a functional design specification document for a project that we've done. And basically it identifies how we are going to program this machine, more so in a written format rather than a programming format. And it's a very detailed document. So many of our engineering team needs to have a technical writing competency, and in some cases we have people that specialize in that. So that's another discipline that I didn't really discuss when I gave an overview of the system, but it's a very important aspect of the communication process with our customers to be able to create these kinds of documents and convey those to our customer as well.
And then I had another question. I was wondering if you guys could give a little bit of insight of what advice you would give to someone who's researching careers in the automation field, and what certain things should students look for in a potential employer.
Todd, Adam, you want to each take that one?
Yeah, I'll go first. I think that the first thing that you should really look at is you should look within yourself and think about what it is you enjoy doing, because if it's very important to choose a career path or choose a job that you're going to do something that you enjoy and you could see yourself doing for a long time. And if you're a mechanical type person, then obviously you're going to gravitate more towards either the mechanical building side of things or the mechanical engineering type thing. If you're a process type person, then you're gonna be more involved in process engineering or developing things like that. So I think it's really important to know yourself when you're looking for a career path. I'm sorry, what was the second part of your question?
I was just saying, any advice that you have to give the educators to bring to their students on looking for potential careers, or you know, what Eclipse Automation would look for when looking at a student's resume.
Yeah, just you know, if you're filling out a resume and you don't have a lot of working experience, one thing you can put on there, always put on there, is your hobbies and what you're interested in. Because an employer, like, look, when I'm looking through resumes, I'm going to look for that, and I'm going to look for what's the person's true interests are and what they enjoy doing again, and I would help guide that person towards something like that. Todd, did you have anything?
Well, just to add to what you've just mentioned, Adam, I do think listing and lack, when they have lack of experience, just showing some ambition to have an inclination to figure things out and work on things is something that's very attractive when we're looking at applicants, because, you know, like I said, we're essentially a pathfinding company, so we need people that kind of can think out of the box and troubleshoot and problem solve the applications that we developed. It's not like they can just go, you know, pull up a menu and pick this solution, or this solution. They've got to want to, you know, have that creative drive to maybe identify the next solution that should be on that menu for the next person. So I think just having some creative ambition is really a key for you know, young applicants that are limited in experience or education.
And I'll just kind of add to that too, is that especially with the diversity of disciplines that we employ, that there's such a wide range of education levels, right? So as a society, we push more and more emphasis on longer and longer post-secondary educations as a starting point, right? You need to have a 4-year degree, you need to have an MBA, and you need to have all these things, and it puts a lot of pressure on students to be able to do that, and it's not always required. And we have the ability to track through a career progression. Our CEO started out as an apprentice machine builder, right? And now he runs a company with 800 employees that's worldwide, and it's just learning as you go about it. And as we kind of talked about that continuing education, he went back after 5-6 years and got a diploma in business and administration, and just kind of worked on the experiences that he has learned, kind of working with customers as a machine builder, right? And that interaction, and just how you have to negotiate every day with team members and customers and whoever else, and kind of work your way all the way up to the CEO. So there's really the sky's the limit really in where you can go. And it doesn't have to always, yes, there's certain positions that require a foundation of education, but that doesn't have to necessarily define your career path either.
Wonderful. Well, thank you so much for those great responses. I think that's really beneficial for the educators to hear, to bring back to their students that not everyone has a traditional career path, and you know, there are other opportunities that educators can bring back to their students. I had one more question. Just kind of wanted to learn a little bit more about who your mentors were, and you know, in your early career, who you looked up to, and what kind of skills and traits those people had.
I can speak to that first. So I've been with Eclipse since I graduated from college. And I've been fortunate enough to start with Eclipse when we were a small company, and work very closely alongside our CEO for majority of my career. And really, he's the one that has kind of challenged me in different roles and different ways to basically, for lack of better terms, kind of throw me into the deep end on certain situations and just kind of see how that would work, and then be there when I was looking for some support, right? And just kind of being able to work alongside him for the last 16 years has really kind of helped form my career into kind of the role that I'm in currently. So just for a little bit of background, I started out at Eclipse as a mechanical designer. I've got a 3-year equivalent, I guess. So my education's in Canada, but an equivalent to a 3-year, like an associate's degree. And so that's kind of where I started out as in designing equipment, and within a co-op program, kind of learning what I wanted and what didn't want, and kind of came to Eclipse, and then just worked through the different roles at Eclipse in terms of service and project management, and then into kind of more operations management, and just part of that just being learning sales and other aspects that are just kind of naturally part of new roles that I just kind of had to learn on the fly. And so that was a big part of it, right? Is working alongside someone who gave me the opportunity to try new things and see how I was able to work well at them or not, and then to kind of mentor as we're working through some more difficult situations.
I'd like to go ahead and hit that one next. Mine might not be so traditional, but my mentor was actually my father. I grew up watching him work really hard. He was a single father, took care of me and my brother, and raised us from little kids. And he went to work every day and worked a lot of hours. And after about 25 years of that, he decided that he wanted to strike out on his own, and he started a one-man shop and built it from the ground up. And as I was a child, I started to go in and help him a little bit, and he taught me the skills and the trade that I know until I decided to go to college to further those skills. But I would say more important than that, he also taught me to be fair, be honest, and just to work hard. You know, hard work can really make up for a whole lot. You don't have to be the smartest guy in the world, but if you're going to be a hard worker, you know, employers like us and like myself, they're going to take notice of that. And I feel that that's probably one of the best skills I've ever been taught by anybody, was to work hard and be honest. And I definitely got that from my dad.
Wonderful. Does anyone else have any questions? I know the session is going to be wrapping up soon.
So I work with slightly younger students. I work with 6th, 7th, and 8th graders. When we're working with those younger kids, I love to do a lot of engineering activities with them. Is there any recommendation on whether it be CAD or programs to help with the design of following that engineering design process and working them through things like blueprints and stuff like that? Are there any programs or applications that you recommend we start to have them work on to start to build some fluency for you guys?
So I've got a middle schooler as well, so I can probably speak to that fairly easily. But there's a couple of programs that are great for students that are free. Google SketchUp is a great one. It kind of allows people to start learning in CAD, and they can really kind of take it wherever they want. I think there's a program called Tinkercad as well. I don't know all the details of it just because it's something that's fairly new to me and my kids too, but kind of works with the ability to use Lego and things like that. So some of those programs that are free and the ability just to start playing with CAD, and to be honest with you, and I tell my son that too, is he comes up to me with ideas of what he wants to build or projects, and I ask him just to draw it out. just being able to articulate it sometimes just in a sketch on a piece of paper goes a long ways as well.
Yeah, something else I would add to that, like if you have students that are interested in programming, there's like Raspberry Pi is a great platform to learn some programming skills, and there are so many applications and projects that you can develop that kind of really encourages young students to be creative and solve problems. And there's some other platforms out there like that, but I would actively encourage students that have a propensity for programming to look into those types of solutions.
The other one is VEX Robotics as well.
Yeah.
I think one thing I would add is, and I know this from experience with my children as well, is Minecraft. Minecraft it's not a CAD software, but it works a lot like mechanical design. You're taking a square block and you're building something out of square blocks, and it may be more geared toward, maybe better for younger than 6th grade, but I'm sure 6th graders enjoy it as well. But it's not just a game. It actually can teach skills that would be useful in a design thinking situation. And then don't ever discredit YouTube, because any of these softwares that we just mentioned, I guarantee you can type them into YouTube and find 100 videos showing you tutorials on how to use those softwares. So, because most of the time you get excited about a software like that and you install it and then you start looking at it and you kind of get scratching your head and you don't know what to do because you don't know what anything does. But it makes it real easy when you can watch a tutorial on YouTube that shows you exactly how to do things. You can learn quite quickly, I think.
And then before we jump off, we had a question in the chat from Deborah. She is wanting to know if she's able to talk to students about your company and employment opportunities through Zoom. She's a magnet engineer. She's at a magnet engineering high school, and she would like to share your information with another engineering teacher.
Yeah, we would definitely be interested in talking to the teachers or students and presenting our company and the industry. And yeah, you're more than welcome to share our contact information.
Wonderful. Well, we're right about at 5 o'clock, and I just want to thank you for attending our session, educators, and thank you again to Jason, Adam, and Todd for doing a wonderful presentation and showing some really great videos as well. So I believe that is it for the session, and then educators, we will see you guys tomorrow.
Thank you very much.
Okay. Thanks,
And
everyone.
then Jason and Adam and Todd, if you would like for me to share your PowerPoint with the educators, if you want to send that over and I can upload it to our resource Dropbox.
Yep, we will do that.
Perfect.
And then a little bit of information on the apprenticeship programs as well.
Wonderful, wonderful.